Bismillah. So we have started a bit on the concept chapter 4, right, where we'll be learning about moment. Okay, so we'll continue on. So for this part, you should be able to, at the end of this, you should be able to understand what is moment and also calculate moment in 2D and also in 3D. Right? And why is this important? I think we have touched on the concept, some of the concept, where the application of any force when we have the distance, it will result in tendency for some form of rotation. So we need to know how to quantify, how to measure, or how to actually calculate statics. Right? Now, so first the definition of the word itself. What is moment? Moment of a force about a point provide a measure of tendency for rotation. And another word is torque. How many of you are familiar with this? For those who are familiar, where do you hear this? Kat mana dengar? Oh, meaning you learn using this word?
Yes.
Okay. And I think some of those who are interested in car and automotive, sometimes you might heard this one in those referring to the power of the engine, it's measuring the power of the rotation there. Right, but in the syllabus here we will use this term moment. Basically, it's what is it? It is a measure of tendency for rotation, meaning the higher the moment, the value is higher, the tendency for rotation is higher. That's basically it. And the first type of moment, we have different type of moment that we'll be learning. So the first type of moment is moment about a point. Right? Okay, so how to measure? So basically, if we have a point here and then a force there, so the calculation is given by m equal to F times T. Right. Now, so if I'm to draw it here, for example, if we have a point here, a point O, and then we have a force here, then should be the distance, the perpendicular distance D, so M of point O is given by F times D. This is a scalar question. Now, make sure you understand that MO is not a short form of moment. This is moment about point O. So if you have point A here, then you write MA. Okay. Of course, if this is the case, let's say, then the perpendicular distance is here, let's say D2. So moment is F times D2. Right? So as you can see, the important point that you have to know is where is the point. Meaning we are considering there should be a force and it creates a moment about a different point. And what is the point that we are talking about? And the distance should be the perpendicular distance from the point to the force. Right? This will be perpendicular also. Right? So if we have point here and then force like this, can you imagine where the distance is? Should be just perpendicular like this, right? What about like this? If you have point here and force here, can you imagine the distance? Yeah, we have to extend this one, and this will be D, right? So as long as you can you understand that one, then you know how to apply this F times D, right? So by definition, D must be perpendicular distance, right? So that's the scalar, and you can see that. Can you imagine the rotation too? Because for this particular case, it will rotate clockwise. For this particular case, it will rotate clockwise also. If about point O, it will rotate counterclockwise. If this is about point A, it will rotate clockwise. Can you imagine of this, or Is it something confusing?
No, it's confusing.
Confusing. How many of you cannot imagine where is the rotation? One. Only one. The rest of you can. Right. So the important point is, because there's two things. One is where the force and what is direction, and then the point, right? So in this case, for example, let's imagine about this one, right? So if I have a paper like this, so if we are talking about moment about point A produced by this force, then you can imagine that you have a pivot at point A here, and then the force here is going in that direction, right? And you can imagine what happened to the rotation. Similarly here, if this is the case, moment about point O, then the pivot is here, then if you have force in that direction, this will be the rotation. Right? Of course, I have to use this one because I cannot rotate. What? But those applies to any. So now you have to understand that, because the rotation is not just because of the which direction of the force, right? Meaning, about this point, this force will produce which rotation? It will produce clockwise, right? This force, about this point, also clockwise, right? So it's not because of the direction of the force. Meaning this is to the right, this is to the left, right? It's relative to this one, right? And if this is about, okay, if it's about this point right now, this one, the force here will be producing clockwise or counterclockwise? Counterclockwise, right? This one? About that point? Clockwise, right? So any problem there? Because this is important that for you to be able to imagine which direction it is, clockwise or counterclockwise, right? So those are this. And also you have to be able to imagine all the perpendicular distance, right? The distance must be perpendicular distance. Alright, so with this equation m equal to ft, so you should be able to also detect that, as we have said, this moment is tendency, it represents tendency for rotation. The higher the value, the higher the tendency for rotation. So there's two ways to increase m, right? Either you increase f or you increase t, right? So that's why, for example, when we try to turn something, right? If you have, let's say the hammer example, right? Okay, something like that, and then we have a nail that we want to take out, right? So the easiest one is if we actually apply it here compared to here, right? Why? Because the distance, the smaller distance will produce smaller m, while the bigger distance will produce bigger m with the same force, right? So that's the explanation in that sense. Alright, so there's two ways to increase it, either increase the force, or normally the easier way when we design is to increase the distance, right? Okay, any questions so far? Right. Now, as shown, this is d is perpendicular distance from the point to the line of action of force. In 2D, the moment is either clockwise or counterclockwise, right? So when we calculate for 2D, normally you have to whatever value in the end, and then you have to say it's clockwise or counterclockwise. Right? There's only two possibility in 2D, right? It's rotating that. In 3D, it will be more interesting because it can rotate about any axis, right? Now, in this case, or if I'm to redraw it here, so if this is the force, that is the point, and the force is here, right? Point O. Can you imagine the distance, the perpendicular distance D, and how to draw it? What do you do? Basically, you extend it here, and this distance D, right? Now, that's straightforward. It's just that in normal calculation, this D will be quite difficult to calculate. Can you imagine that? Meaning in any structure, normally the distance at any given angle like this tend to be more quite difficult to calculate. It can be calculated, but it involves a long discussion, calculation basically, right? So what we tend to do is we make it simple. We have learned that we can actually resolve this into components, right? So let's say we have fx and fy. So the effect should be the same, right? The effect of this f and the effect of the combination of the two components, right? So if we have done this, then we can add the two effect in terms of moment about this one, and the answer should be the same, right? And this way, can you imagine what it will be the distance if we are to calculate fx about point O, the moment, where will be the distance? How do you get, for fx, what is the perpendicular distance with point O? Basically, we do the same thing, right? Extend this one, and then this one will be d. Let's say this is d1, right? And for fy, this one will be d2, right? And normally, to get this distance is more easier, right? To get perpendicular, the vertical or horizontal distance is more easier normally in any structure, right? So this is what we do normally. So in this case, the original, what is the original? Original is f like this, and the point is somewhere here, and then you extend, and this is t, right? So summation of, in this case, moment about point O, if this is point O, equal to f times d, right? And it will produce which direction? Clockwise or counterclockwise? It will produce counterclockwise. Oh, this should be obvious here, right? Now, what about this one here? How do we calculate the moment? So we have to calculate summation, right? So let's say summation of moment about point O. And to calculate this, we have to decide which direction will be positive, which direction will be negative. So let's say if we take counterclockwise positive. So for fx, will it produce clockwise or counterclockwise? It will be clockwise, right? If you take counterclockwise positive, then it means negative fx times, the distance is d1 or d2? d1, right? And then for fy, is it positive or negative? Why positive? It's counterclockwise, right? So positive f2 fy d2, right? And the answer should be the same. And the answer should be positive because this obviously is counterclockwise, right? So this will be what we normally do in our calculation. Even though the answer is the same, this will be much more easier to do because of the factor of this one is much more easier to detect from any diagram. This one, you have to use a lot of trigonometry to get this length, right? When we have whatever structure and then to get this particular length, you can try, but it will be normally it's not worthwhile to spend that much energy here, right? So this is generally the step that we do. We resolve and then we calculate and then we get the summation. The answer should be the same, right? So it's a game like this, and in this case, yeah, okay, because this is positive negative because the meaning fy d2, or in this case it use a and b, right? As long as you understand the concept, right? And this one, if you have a slide, this is not an equation, do not memorize this. Why is this positive, why is this negative? Because of what we discussed. This is clockwise, this is counterclockwise. If, for example, the force is here, and the point is here, right? So let's do this one. If this is F, so we have Fx, Fy. For x, can you imagine the distance for Fx? If this is distance, right? Let's say this is d1. For Fy, this will be d2, right? So if I'm taking, let's say I'm taking about, let's say this to A, so MA. If I still take counterclockwise positive, for Fx, is it positive or negative? Negative. Fx times d1, right? For Fy, positive or negative?
Positive.
Negative.
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 Positive.
Positive.
Negative.
Is it clockwise or counterclockwise?
Clockwise.
Apa which point?
Clockwise.
Clockwise. So if it have counterclockwise or positive, should be negative. F1, F2, right? So the positive and negative. So my point is, do not memorize things like this. This, why is it positive and negative? It's exactly because each of those produce either clockwise or counterclockwise. So it can be like this, it can be like this, depend on where's the force and where's the point. So you have to understand where this comes from. But if you memorize one is positive, one is negative, then you will get it wrong, right? Okay, do you understand this? Of course, for another guy beside you, sometimes they can already detect and they do not like negative sign. They say, I want to take positive clockwise. Then obviously they will just get fx d1 plus y d2, right? Both are correct in the sense that if they do it like this, and obviously this will be clockwise in the end, right? Meaning that in this case you will get a positive value in the end. It means it's correct clockwise. This one in the end you will get negative something, meaning what? Meaning it's clockwise, because we assume positive counter and you get negative answer, it means it's clockwise. And so that's the meaning of the positive and negative. And that's why you have to show what you mean by positive and negative here when you do the summation. If you do not declare, then it's not clear what is positive, what is negative, and it doesn't make sense. Okay? So not the different sign and the term, the typical sign convention. Okay, normally, just like for example, if you do summation of fx equal to 0, right? You are free to say I want to take this as positive or this is positive, right? But generally, convention-wise, normally this is taken as a general. But you still have to declare. But in certain cases, for example, because when we do 3D, we cannot declare anymore. You have to just use the x is positive, is the x, is the positive. You cannot change it, right? So to be consistent, sometimes this is easier. So similarly for summation of moment. So normally counterclockwise as the general positive, especially when you go to 3D. Why? Because of what we will cover when we will cover that one. Because of the right hand rule. Have you learned about the right hand rule?
Yes.
Because from the perspective of this one, it's counterclockwise. This right. So it's easier just that will be the positive one. So it's clockwise is negative. So this is what it mentioned here, typical sign. But for calculation, it's still valid. Meaning you still have to declare normally, right, to avoid any confusion. Okay. We can determine the direction of rotation by imaging the body pin at O and deciding which. Okay. So that's basically what we do with the paper just now. Any questions so far? Are you following still what's going on and how to deal with this? Right. Now, this all might seem easy still, and it will still be easy as long as you understand. But it's not confusing because we only have the force and the point. Normally the question will be given, there will be some box or whatever. So that is the thing that you have to be able to translate from the actual diagram to what you need. You need just the force and the point. And we'll discuss on that later. Now, while finding the moment of a force in 2D is straightforward, when you know the perpendicular distance g, finding the perpendicular distance can be hard, especially when you are working with force in 3 dimensions. So a more general approach to finding the moment of a force exists. This more general approach is usually used when dealing with 3-dimensional forces, but can be used for 2D also as well. This more general method of finding moment of a force uses a vector operation called cross product of two vectors. So basically, what we have discussed here, we can still easily do in 2D, but in 3D, for example, if you have a force like this, and then we have a point somewhere there, to get that actually perpendicular distance will be much difficult, right? And even if you resolve x, y, z, still the perpendicular distance is quite difficult. So there must be some better way, and normally in 3D, the easiest way is to use vector operation. So for vector, we have covered dot product before. Now we will cover or refresh on cross product. Have you learned anything about cross product before? You have. Alright. So we will just the new thing is how to use that. Let's see, perhaps. So cross product. Okay. So this is where the right hand rule comes into the picture. But so if you have learned cross product, you have learned about the right hand rule. So everyone understand what the right hand rule. So if you have, so basically if you have vector, if you have A here, B there, and then so in the vector form, C equal to A cross B. Yeah. Okay, this is cross. So this is one reason why for multiply we don't use this, even though in school we use this for multiply, right? But in engineering, this is already used for cross. And multiply and cross is different. Dot is different, cross is different, multiply is different, right? So how to understand this? But you say you already understand, right? I mean, how come it's like this? Okay, so if the right hand rule basically is, let's say, vector A is here, vector B is here, right? So what you do with your right hand rule, basically, if A cross B, right? So first you point your forefinger at the first vector, vector A, and then you bring it to vector B. Meaning, if this is the direction, then you go there, right? Meaning from vector A, point shift towards vector B is there. This will be the resultant of C. So if B cross A, then you point at B first, and then you bring at A. You'll notice that C is the opposite of A cross B, right? So that's how you get if C, if you use C still, if you C equal to B cross A, so it's the opposite, right? So that's basically what. So if you understand that one, can you detect what is I cross J?
Again, I don't understand the hand.
Oh, you don't understand what do you do?
Yeah, the thumb moves.
Okay, the thing that you do, okay. If we have, okay, if you use this plane here, right? If I have vector A here, vector B here, right? So first, what you do is you point your forefingers to the first. If the question is, what is A cross B? So you point at A, the first vector, and then you bring it to the direction of the second vector. So then you bring it here, naturally you get to this direction, and then the cross product is your thumb, meaning it will go out from the whiteboard here. If you use if what you want is B cross A, then you the first one is you point at B, but to get to A, of course you cannot bend it like this. So if B cross A, your thumb is actually going into the whiteboard, right? So that's the meaning of the So if you have, for example, x-axis, y-axis, right? So I cross J will be what?
G.
Yeah. Okay, right? Because why? Because I is here, right? J is here, right? So if you do that, your thumb going up will be K. So J cross I, you get negative K, right? K. So do you understand what's going on? This is just in terms of the direction. We haven't covered in terms of the value yet, but meaning to understand what's going on there, right? Because this is quite important. So if you have vector A something like this, vector P something like this. Can you imagine where the rotation is?
Yes.
So A and B, so it's somewhere along that line there, right? It's perpendicular to the plane. So that's basically the idea. So basically the resulting moment there is somewhere in the 3D space. So the resultant will also have ijk in that sense. Right. So in general, the cross product, erase this first. In general, okay, this is just a side story. When I learned in my undergrad, I have quite a, not to say weird, but interesting lecturer. Because he always have some way to make the student memorize something. For example, say, you understand the general equation? We have that phrase, general. Do you understand general? You know, general. So he always have that kind of character that makes student alive, meaning awake in the class. But I'm not like that, so unfortunately. So anyway, in general, the cross product of the two vectors A and B results in another vector C. Right? Now, if you still remember, if you have A dot B, do you have a vector or scalar? You get scalar, right? So this is where it's different. So A cross B, you will get a vector, right? So that's one thing that is different. So the magnitude and the direction of resultant vector can be written as this one here. Right? So if you still remember, if A dot B is A B cos theta, right? In this case, it will be sine. So the effect of perpendicular and on the same line is different. It's opposite basically, right? So in this case, as you can see, if from this equation, right? If A and B is on the same line, what will be the result?
Sin 0.
Do you understand what my question is? Okay, before, right? A dot B is A, B cos theta, right? So when theta is 0, meaning it's the same line, it will result a value, right? Because this will be 1, then you have whatever value there. When theta is 90 degrees, it gives 0, right? But here A, B sine theta, and then you have the unit vector because you have to this is the magnitude, and then unit vector for because it will be ijk. So when you get theta is 0, what do you get?
Sin 0.
You get 0. When theta is 90,
1.
this portion is 1, and then you have a value, and you have in between you have still also a value, right? So of course, from the right hand rule perspective, if it's on the same line, right? Meaning A and B is on the same line, so A cross B, it doesn't go anywhere, so it doesn't create that your term, right? So that's how to relate these things, and how to differentiate between dot and cross. But anyway, so this is the calculation. But normally we rarely use this one, right? We normally use this one, and then we will solve the matrix. Anyone remember that one? So as shown, you see is unit vector of the perpendicular. So the characteristic is, if you understand the right hand rule, the C will be perpendicular to both A and B. Right? This will be 90 degrees, it will be 90 degrees. Just like your, right? Meaning if you A here and B there, so this one is perpendicular to both because your thumb is perpendicular to this plane basically, right? So that's the characteristic of cross product. Okay. So we have discussion, right? So I cross J becomes K as the reason that. So this is basically just to relate everything, right? So I cross J equal to positive K. When you rotate like this, positive. J cross K becomes I. K cross I becomes J. Or if you give J cross I become negative K, etc. Right? But this one you can easily understand if you understand what we have done before, right? So if I and K become what? Negative J. Can you imagine that?
Yes.
So I believe you can imagine anyway what's going on, right? As long as you have the correct axis, meaning if you have x and y here, z must be here, not downwards, right? Meaning if x is here, y here, z must be here, right? If this is x, this is y, z will be here, right? Etc. So that convention you cannot switch. I want to put z here. No, that will mess everything up, right? So as long as you understand that one, so meaning for example, if you have J cross K, okay, in that sense it will be I, etc. Right? So as long as you understand the concept, you should be able to derive this easily. Now, but how we solve is basically with this one, right? Do you remember this one?
Yes.
So just to see what you remember. So if A is, let's say use a value to make it easy. So 1i plus 2j plus 3k, and B equal to, let's say 4i plus 5j plus 6k, right? So if you have A cross B, what are you doing in the matrix? What do you write? First you write I, J, K, it's actually like that. And then you write the first vector, which is 1, 2, 3 here. And then you write for the second vector is 4, 5, 6. Now, how do you normally solve this one? What do you have learned?
For I, J, and K.
So you use that method, is it?
Yes.
So meaning you have
E times
I. So in that case, what? You close this one, and then
2 times
this
6
becomes 12 minus 15, like that. And then what? Next? Minus J,
1
right?
times
And then you close this one. 1 minus 6, and then 3 and 4 minus 12. And then plus K, so you close this one. So 5 minus 8. So everyone is used to this method. Anyone who what's going on? Anyone who do not know what's going on here? I just want to check. Do not pretend. If you don't understand, make sure you understand. If you already this is familiar, then you can just apply, right? Anyone who know are familiar with another method? Normally, I think the most standard way that I think most people learn is this one, right? Anyone who from here they go like 12i and then plus 12j and then plus 5k and then minus 15i and then minus 6j and then minus 8k. Anyone who are used to use this method? No one. It should be the same, right? If you notice 12 minus 15, it will become, actually it's 12 minus 6. But when you switch here, that's why you have negative here. Actually this method is derived from here. But this is based on memory, so they just put plus minus plus. So even you don't understand why this minus, just apply, right? But why is this minus? Because it originally it should be this minus this, this minus this, this minus this. But when you close here, you still take this one. So you have to negative there. Right? So itu pertama lah apa aja lah. And then 5 minus, okay, right? Because this is basically similar to, and have you ever learned that you extend the two column? Like I, J, and then you 1, 2, 4, 5, and then this. Basically it will result to that one, right? So I'm just showing there are various ways, but as long as you can do whichever way and get it correctly, that's all that matters. But it's good to understand where it comes from for engineers, because then you can play around with the formula. Otherwise, to apply you can just memorize and apply. So there's nothing new here, right? So everyone, because it seems everyone know what's going on, but I just want to make sure so that no one is left behind. So it's quite bad if I assume everyone is okay, but someone is struggling, not even know what's going on. So everyone is okay? Right, I think normally the slide also it will use the, you will show that the, I'm not sure if there's a name for this method, but basically the one where you close this one and then this, and then close this one, this, and then close one, that one, and you have to memorize this is negative sign. Alright, so if you forgot this negative, then it will be wrong, right, in the answer. So that's, okay, this is not statistics, again, this is mathematics. This is just cross product that we will apply. So how does it apply? How does it apply? Because in our calculation we have cross product, so this is where we have to apply this method, right? Because this is just mathematical calculation. Alright, so going back to statics, moment and 3D can be calculated using 2D approach, but it can be difficult. Again, it's repetition of that one. So that's why we use cross product, and that is the equation. So if you have any point, and then if you have a force, so by equation, this is in scalar is just m o because point o f times d, and then clockwise or counterclockwise you determine from visually see. But from vector, it is r cross f. It shows there, right? And r is what? R is from point to force. We have understand what is position vector before, right? It connects between 2 points. So we have to know between what and what is from the point to the force. R. So if you get this coordinate, you can easily calculate that one. So my question to you is this correct or should it be here? And the first one or second one?
Second.
Or is it here? Or if I stand here, is it here?
Oh yeah, it should be perpendicular.
Okay. So if you have already read here, it's from the point O to any point on the line. So if you use this one or this one or this one or this one, the answer will be the same. So that's why it is easy. You don't need to care about perpendicular. This one, this must be perpendicular, because if the distance is not perpendicular, the answer will be different, right? Meaning this change, this change. But in this case, if we change this one, as long as from the point to any point on the force, the answer will be exactly the same still. So no problem. Right? And then f is f. Then if you can get what is f in vector, you get this one, and then you can apply the matrix and solve. Any question? So make sure you understand this one. So m equal to r cross f. R is from the point to the force at any point, doesn't matter. As long as it's on the point, on the force. Right? Even if you extend here, still the same. Meaning r will be different. The resultant, this one will be the same. We can check after this if you don't believe me. Mana Daniel keluarkan nas? We can test this one. Okay, let's test because some of you doesn't seem to believe. Okay, okay, what we have done, this is to relate. Do we have what is our time? Okay, we still have time, right? A lot of time left. Okay, let's see if we can do this one, right? If you have this point, let's see. I have force like this. Let's say it's 10 Newton, and then we have 3, 4, 5, and then this position here is basically let's say this is 2 meter, 5 meter. That's it. For scalar, meaning the one that we learned before, right? If you use 2D, if you consider this 2D, how to calculate moment about point O of this force 10 Newton? let's say we do summation of moment, right? If I take counterclockwise positive, right? So what do you do first? You resolve. So when you resolve into x and y, what will be x? This one in value. How do you calculate this one? Basically 4 over 5 times 10, right? Equal to 8 meter. This one is 3 over 5 times 10, 6 meter. Anyone still have any problems to apply this one? No? Make sure you know this. Alright. So now basically we have the horizontal and vertical or x and y component, right? So for this x, does it produce clockwise or counterclockwise? Or positive and negative here? If you take counterclockwise is positive,
Clockwise negative.
it will be negative. Force is 8. If you still remember m equal to fd, right? The distance will be 2. Everyone agree? This is perpendicular and this is the force. And then for this one, is it positive or negative? Negative, right? It's still clockwise, right? So if this is positive, then it's negative. Then 6, the distance is 5. If you calculate this one, what do you get? This is minus 16, this is minus 30, minus 46. What is the unit? Okay, what is this unit? Meter, and this is? Meter, right? This is also Newton meter. That's the unit. Oh, we haven't touched on the unit, right? Okay, so the unit is Newton meter. If this is millimeter, Newton millimeter. Alright. Any problem here? No. Okay, this is scalar. So if I am to use this exact example in vector form, right? Let's say the original. This one, right? So can I use this? Or can I use vector in this case? Vector is m equal to r cross f, right? So in this case, r is from where to where? If I want to apply. Yeah, so the easiest point is this one. So let's say this is your r, right? R will be what in this case? So 5i plus 2j. If in 3D it becomes 0k, right? What about f? What is in terms of vector? Okay, basically you have got this component of 8 and 6, yes, right? So 8i minus 6j left plus 0k, right? K is where k is going out of the whiteboard, right? So it's 0. Okay, how to apply this one? So m equal to r cross f. So if you do the matrix, what is the first line here? I, G, K. What's the second line?
5,
0. What's the third line? 0. So if you do that close one, so for I, what do you get? 0 and 0, right? 0 minus 0 basically, right? So minus j. What do you get? 0. So 0 minus 0 also. Okay. Plus k. This one is minus 30 minus 16. So in the end you get minus 46k Newton meter, right? How to understand this? What that? Okay, it's the same, right? But what is this k? K meaning your term is negative. Okay, right? Okay, in this case the answer is not complete. This is clockwise or counterclockwise? Based on that, should be clockwise, right? You should already see that it should be clockwise here, right? If you, the original force here is clockwise, right? Now, Okay, so if you look from the perspective, because this is the plane, right? From x and y perspective, z is going up, right? So this means negative k, meaning your thumb is going negative k, that's right?
Yeah.
So can you see it's clockwise,
Yeah.
your finger? So basically that's the meaning of this one. Meaning that's the meaning of negative k. Meaning it's clockwise because your thumb is going negative k. So it's exactly the same. It's just to show the calculation will give the same thing for scalar and vector. Of course, for in 3D we have RF etc. Then normally this it will be too difficult to do this one. So it will be this one, right? And of course, if you have in 3D, then this will not be 0, so you'll have ijk. And the meaning is, your thumb is there, the rotation is about that axis, like that, or like that, right? So do you understand what is going on and what's the meaning of whatever value that we get? Any questions about? All right. So this is just the application of this one, right? So I think you know what's going on already here. This is basically when for I, J, and K. The unit is Newton meter, as we have discussed. The physical meaning of the above equation. Okay. Example. Okay, let's take a look at the example. Now, of course, in example, this is an example, a simple example still, but the thing is, you should be able to visualize, or you should be able to transform whatever given to something simple as this. Because the only thing that matter for us is where is the force, where is the point, how to link the point and the force. But either 2D or 3D. Whatever shape of the object is not important, right? So let's try this one. We have a 100 Newton force there. Angle is given 345. Find the moment about point O. Okay, so if you understand what's going on here, try to take 2 or 3 minutes and solve this one. This should be 2 or 3 minutes. You should be able to solve already. Get the moment about point O. Any problem? Anyone face any issue? Now the first thing, of course, if you go back to the IPE, still remember that one. So you have to understand, okay, what the question one? The question one is what is the moment produced by the force? Point. So the only relevant point is, okay, my point is there. The force is where? The force is somewhere there, in this case, right? 100 Newton, 3, 4, 5. That's only the relevant information that we want, right? And of course, how to relate this one, we have the 2 meter and 5 meter there. Of course, when you draw things like this, make sure it is quite clear where the point is, because the point of action is here, not here. Do you understand? It's different. Right. Alright. So what do you do? Let's say if you take summation of moment about point O, this is point O. If you take counterclockwise as positive, what do you do first?
Find the Fx,
Okay, you resolve. So you get, so this because it's at this point that's how this one. If you draw here, that's wrong. Do you understand? Why? Because if you draw it here and here, the distance is different, right? This is distance, this one is a different distance. So fundamentally it's wrong because the action of the point of action is here. So it must go to that point. Here, then somewhere else, right? So in this case, this is 60 Newton, is it? 80 Newton. Anyone have any problem, difficulty to get this one from this angle? Confirm? Okay. All right. So then for this one, it will be negative, right? So negative 80 times
2.
2.
Yes.
And for this one, is positive or negative?
Negative.
Negative also. 60 times 5. And then you get also in the negative. Meaning positive, meaning clockwise or counterclockwise? Meaning clockwise, right? So it's pretty straightforward. Anyone face any problem? Which one? This one. Okay, how do you get the perpendicular distance? The easiest way is you extend this, and then this will be the perpendicular distance. So it means this one, right? Now, for those who meaning cannot straight away visualize, just extend. Just extend. Then it should be obvious which is which, right? Because sometimes visually when you look without that one, it doesn't become obvious which distance is perpendicular, right? And if you make a mistake like that, it's quite, in terms of marks, it's quite a pity way to lose marks because it should be straightforward, right? Any other question or anything? So this is where I think if you make some exercises, you will notice where you tend to make a small mistakes and try to avoid in the exam, right? Because just to see and okay, that's not, it doesn't really challenge you where you tend to have small mistakes and lose the marks, right? Any other question? Anything not clear? So this is your word. It's still very easy because the structure is easy. Only one force, not that difficult, right? So you get 460 Newton meter clockwise. In the exam, that everything have to be there for complete mark, right? The value, the unit, and the direction. Okay. Even though it doesn't say give the direction, you have to understand that without this one, the meaning is incomplete, right? Okay, it's use it that way or that way. All right. So next, is there any other example? All right. So this is a 3D example. Can you see the diagram there? Okay. What to do here before we start to calculate? Okay, first the question. We have the structure there, and then we have the force F1. It's already given in vector form to make it shorter. So find the resultant moment by the force about point O. Do you understand the question?
Yes.
What is the resultant moment?
So,
Find the NP.
Because we have moment produced by F1, moment produced by F2,
Total.
and the total
And one.
moment, right? So what is your plan? What do you do?
My moment over
What equation will you use?
F.
And R
Okay, first the question is vector or scalar you want. If vector, then M equal to R cross F. It's not times, it's cross. The meaning is different. Time is just multiply, right? So it's cross F. Right? So as long as you can get R, as long as you can get F, in this case F is given straight away, then you can calculate, right? Now, in this particular case, there's two ways to solve. Either you do for, meaning for F1 and then for F2, meaning that R cross F1 plus R cross F2. Right? Or, because this, now, is it the same or different, this R?
R is the same.
For this question, it's the same because it goes to the same point, right? And because it goes to the same point, if you it's this, if you get FR F1 plus F2, so you can just R cross FR. It'll be the same. But this one is only because it goes to the same point. If F1 is here, F2 is here, you cannot simply do this because R will be different, right? So which one do you want to try? Is it this one or that one? That one. This one. It's easier, is it? But you understand that? Meaning in another equation and another problem, if you have to do separately, you should do separately. Now, if you want to do this one, so FR equal to can you do straight away? Negative 100I
130
plus 130J
175.
or plus 175. Okay, what is R?
R is 4
For I
plus 5G plus 3K.
plus 5J plus 3K. Any question about any of this? Why suddenly become like this? For example, it's trivial addition of the two. Then you add X, add Y, add Z. For R, any problem at this point? How to get from any? No, right? Let's make sure. Okay, ini. Okay. So what to do? You just apply the. If you apply M to R cross F, then you apply the matrix I, J, K, and then what's the second row? Which one? It should be R, right? So 4, 5, 3, is it all positive? Positive, right? And then negative 100, 150, 175, right? Should we show, meaning you know what to do next? Right, so I is this, that minus this one, for J, this minus J, this minus this one, K, this and this one, right? So the rest is basically just mathematics. Right, so as long as you can identify what is the force, what is the position vector, you know this equation, you plug in, you can just calculate. Right. So if there's many forces at different points, then it's just a repetition of the same process, and then you add all together at the end, or to get the total M. Right. So we just go to the solution here. The slide also use the same method where you calculate the resultant first. Right. You can try to calculate separately and it should be the same. Right, the answer. So you get also, in this case, okay, make sure you are aware of the unit. What's the unit before? It's in kilonewton, is it? Yeah, okay, because that's in kilonewton, the distance in M, so that is why You have kilonewton meter. NIJK. Any question? Everything straightforward? Alright. Concept quiz. Okay, if a force of magnitude F can be applied in 4 different 2D configurations, meaning you can apply the same force at this direction, this direction, this direction, and this direction, P, Q, R, S. Select the case resulting in the maximum and the minimum torque value on the nut. So which one will give you the maximum, which one will give you the minimum? This one maximum? That's minimum. Everyone agree? Why you say this is maximum? Yeah, the maximum is perpendicular, right? Do you understand that? Minimum. In this case, the distance is 0, okay, right? In this case, the distance is the maximum distance. This is the distance, right? For this one, what is the distance? If you want to calculate, it will be this distance, right? Perpendicular. So this one is shorter because this is the hypotenuse, right? If you can imagine, like this one, what is the distance? Okay, for this one, where is the distance? Can you imagine? So you have to extend. It's basically perpendicular, right? Perpendicular. Let's say this is perpendicular, right? So obviously this distance perpendicular here is shorter than this hypotenuse of this triangle, right? So the maximum length that you can get is the hypotenuse, which is actually this one, right? So that's the logical. That's why when you apply, we instinctively know it should apply perpendicular to the hammer, etc. Right? Otherwise, we are actually wasting our energy. Not useful. Right. M equal to R cross F. Okay, if M equal to R cross F, what will be the value of M dot R? This is just to see if you catch the concept and you know the relationship. This one? Oh, kita nampak ni? None of the word. Okay, how many of you say A? Anyone? B? C? Kalau sini macam mana dapat? How do you get square? Oh, because you plug in here. D? Okay, the concept is okay. How does if you understand this one, how does these two relate to each other? In terms of, can you imagine how this and this? What is the angle between the two?
90 degrees.
It's perpendicular, right? If it's perpendicular, when you dot, what do you have?
Cos 90 is
0, right?
Zero.
Right? So it's 0. Anyone who do not understand that? Because if you understand this, meaning that M is perpendicular to R and M is also perpendicular to F. But your thumb is always perpendicular to whatever this one, right? If it's here, then your thumb is always going perpendicular to wherever your finger go, right? So if this is perpendicular, when you dot, it becomes 0, right? Like I dot J is 0, right? Because it's perpendicular. So again, so if many of you do not understand that, I think that's interesting to put in the exam. Anyway, so let's try this one. Okay, we only have 10 minutes. Okay, okay, if you see this question, does it seems to be, what is the question? Okay, you have 100 Newton hammer, and then you need to find the moment of force at A, or part point A. Is it difficult or easy? Okay, what do you do?
Find the force in 0.
Do you, okay, this one, is it, will you use scalar or vector? Normally, 2D is quite easy to use scalar, right? But the issue here is that you cannot, it's not cannot. It will be more difficult if you resolve in normal x and y horizontal vertical. Right, because all the angle is given in corresponding to. So the easiest way to solve this one if you have this axis along that line, right? Then it's easier because, and then you have to identify, okay, the point, okay, if I assume the axis is like that, right? So point A is here, and then the force is somewhere there, making exactly 30 degrees there at 200 Newton, right? So if you follow this axis, then it will be easier. If you use the normal x and y, it is much more trickier to get that data, etc. It's longer, right? So what do you do?
Find the force in x.
So first, we get the component, right? X and y. So this one will be 100 cos 30, 100 sin 30. Now, what is the distance then? So this is
450.
This is 450 mm. If you use mm, is 450. This one is 1 to 5. Alright, so if I do summation of moment about point A, if I take counterclockwise positive, for this 100 cos 30, is it positive or negative? Negative. Negative 100 cos 30. What is the distance? 450. And then for that 100 sin 30, is it positive or negative? Negative. So 100 sin 30 to 5 mm. So obviously we get negative something, which means it's clockwise. And obviously from here you should know it's clockwise also, right? Okay. So the thing is, this is the thing. I think as long as you can imagine from whatever given to some simple form of like this, everything should be straightforward. I think the major from previous exam, I think the major thing that many students struggle is whenever they see something that is, wow, what to do with this nail and why is this block? Many they get confused by some diagram, so they do not know where to start. So you have to understand, okay, this is moment about the point. So what's the point? This is the point. There's a force. As long as I know this line, that's sufficient for me, right? So if you have that skill, inshallah it will be easier. If you keep, but this hammer is having, maybe that will confuse you. So do not concern about that one, right? Okay. So as long as you can do that methodology properly, inshallah it will be straightforward. Right. So of course it's clockwise. Any question? So it can be something like this, right? Meaning the axis can be in accordance to align with the structure that you have. Alright, so I think it's already 6 minutes. Okay. Cepat tak ni? Okay, let's see if we can do this in 6 minutes. Okay, the question gives you this structure here. Again, the same thing apply, meaning that if you start panicking, why is this too many curves, and then you will be lost. The important thing is, okay, what is the question? What is the moment of this force? About point A, where's point A? This point, right? So what's the only important point here? What is point A is where? And then F is at point C here. This is F, right? What equation do you want to use? Vector or scalar here? If you can try with scalar, good luck. But if you get the correct answer, but normally the calculation will be a bit more tedious. The easiest one is M equal to R cross F. So F, as long as I can get this into IJK, I'm okay. What about R? R is from what point to what point? C to A or to C? It's from what to what? From point to force, right? So meaning this is the point. So R. So as long as I can get this two, I can plug in and solve, right? So you have to be able to, from this question, whatever angle, this is quite simple actually. The rest is just, okay, to get this one, what is the coordinate? Then you just add up those things, right? Okay, what's the coordinate? A?
550.
No, okay, you already have that. So 0, 0, 0. The coordinate C is
550.
550. This is millimeter, right? And then
500.
100
Negative 200.
minus 200, negative 200. Right?
Yes.
So as long as you get that one, so R will be, basically if C minus A, so straightforward, 550 R. This is in millimeter, right? Plus 400 J minus 200. Okay. For those who want to use meter, then 0.55, 0.4. What about F? Okay, this goes back to, again, chapter 2, right? Make sure, I assume you have already practiced on this one. So, what is the X coordinate? 80. Cos 30. Sin 40. Alright. And then for J, this is positive, right? Then positive 80. If you use the first time, you get cos 30,
Cos 50.
cos
40.
40. J, right? And then, is it? What's the K? Minus 80 sin 30. Okay.
Yeah.
Now, of course, again, for those who haven't done the exercise yet and practice yet, you make sure you practice with the two triangle, right? And you should get that one. Once you get this one, you just plug into this one, right? So it become I, J, K, 550, 400 minus 100, and whatever value there, right? And then it's straight away just calculate. So fundamentally it's
How did I get the coordinates of point C?
which one?
How did I get the coordinates of point C? Yeah, the 550, 400.
How do you get?
Yeah.
Alright, the X coordinate is basically this length, right? Meaning basically this one and this one, right? Can you imagine? Okay, this is okay. This goes to the x one, x towards positive x, going down, and then further positive x, right? So this plus this, so 3 and 2. Why is just this one? Because if you can imagine, this is just going here, down here, so it's still under that one and that. Okay, that's another thing. I think the ability to imagine the structure is also critical in this is still easy because there will be much more interesting with shape. But still, whatever the shape is, you have to be able to first know what you want, right? Meaning if it's curling and whatever shape, it doesn't matter. I just want the coordinate. As long as you coordinate. Do not be all over. So make sure you know. Alright, so 1 minute left. So the rest is it seems short because I just showed the static one. But when you actually want to do the mathematical part, there's some steps further, right? But I assume you know how to do this, and I expect you to try on your own also to polish. Knowing something is one thing, but you can do that correctly without mistake in time is another thing, right? some people can do it without mistake, but they take it too long that in the exam they cannot solve all the question, which is a waste. Some people can do it quickly, but always with many mistakes. So that's also not a good thing. So make sure you practice sufficiently. I think so you can see the solution and the other one. Of course, in the exam you cannot do this, right? Because as you mentioned, we put also the mathematical part also have the meaning. From here you have to show whatever method for MIJK before you suddenly get your answer there. Right. So I think we will stop here. Don't try do. I don't expect you are independent enough and grown up enough to actually take the responsibility to try and polish yourself with some practices. Inshallah we'll continue on the next class. Everyone has signed the attendance. And yeah, I didn't manage to print the quiz today, so it's most probably going to be the next class for chapter 3. Right, chapter 3 we haven't had any quiz yet. So normally we'll start in 2D chapter 3. But there's no
Always three.
whatever lah, equilibrium, right? Okay, we end the class here. InsyaAllah subhanallahumma bihamdika. Wassalamualaikum warahmatullahi wabarakatuh.